Welcome back to Earth and Life Science subject. This is Sir Celoso, your lecturer for today's session. This week, we're going to talk about natural hazards, mitigation, and adaptation. Let's define first what is all about natural hazards. Natural hazards are events that occur as part of the natural cycle of Earth and may cause potential damage to a community. While disaster is an event that causes widespread losses, human, economic, and environmental, and disrupts the normal functioning of a community. In short, a hazard is a dangerous situation or event that carries a threat to humans, while a disaster is an event that actually harms humans and disrupts the operation of a society. Hazards will be considered disasters once they affect humans, but if they occur in an unpopulated area, they will remain hazards. So that is the difference between hazards and disaster. On the other hand, vulnerability refers to the characteristics and circumstances of a community, system, or asset that make it susceptible to the damaging effects of hazards. Vulnerability may vary significantly within a community and over time. That's why there are four types of vulnerability: the physical, social, economic, and environmental vulnerability. There are four types of natural hazards. The first one is geological hazard, which is our topic for this week. It includes earthquakes, volcanic eruptions, and landslides. The second one is hydrometeorological. It includes cyclones, typhoons and hurricanes, tornadoes, floods, thunderstorms, and coastal storm surges. The third one is biological hazard. It includes outbreaks of epidemics, diseases, insects, and other animal plagues and infestations. The last one is the technological or man-made hazard. It includes famine, degradation, pollution, industrial and transport accidents. So those are the four main types of natural hazards: geological, hydrometeorological, biological, and technological hazards. Okay, so let's proceed to geological hazards. For this week, we're going to discuss what is all about earthquakes, volcanic eruptions, and landslides. The geographical location of our country has something to do or often associated with the geological hazards. Its position in the Pacific Ring of Fire tells us that we are not exempted to the occurrences of earthquakes and volcanic eruptions. The tremors in land surface also result in various landslides, which also pose higher risk to the local communities. That's why in this lesson, you will understand how these geological hazards occur, their damages, and how the government act in reducing the damages to properties, and most importantly, as much as possible, promote zero casualty. The vibration of Earth produced by the rapid release of energy in any direction through seismic waves is what we call earthquake. Earthquake is the sudden slip on a fault and the resulting shaking of the ground and seismic energy radiated by that slip. The ground shaking caused by volcanic or magmatic activity. The Philippines is geographically located near the boundaries of active tectonic plates. This explains the frequent earthquakes experienced throughout the country. As I've said a while ago, Philippines lies along the Pacific Ring of Fire, which causes the country to have frequent seismic and volcanic activity. Therefore, there are two different types of earthquake: the tectonic and volcanic earthquake. The areas where earthquakes frequently occur are called earthquake belts. Areas that are at risk to earthquakes may also experience other hazards associated with earthquakes. This includes ground shaking, surface faulting, tsunami, collapse, and explosion. The destructive effects of earthquakes are due mainly to intense ground shaking, or what we call vibration. So ground shaking is the vibration of the ground due to the plate movement or seismic waves during an earthquake. Living things may be disturbed by this movement. Buildings and infrastructures can be damaged by the effect of ground shaking. These structures can also be damaged when ground beneath them sinks or what we call subsidence after ground shaking. The next one is surface faulting, but in other references they call this phenomenon as ground rupture. Surface faulting is the tearing of the ground when the movement of the fault deep within earth breaks through ground surface. Buildings, roads, railroads, tunnels, and pipelines are susceptible to the surface faulting damage. Also, animal habitats may be destroyed or worse, lost due to the breaking of the ground. The third one is tsunami. I know that you are familiar with this one. Okay, so tsunami is a very high, large waves or seismic sea waves caused by the sudden movement of the ocean floor due to earthquakes, volcanic eruptions, man-made explosion, and in some occasion, landslide. The next one is collapse. Small earthquakes in underground caverns and mines due to seismic waves produced by explosion of rock on the surface. Most collapses that occur during earthquakes aren't caused by the earthquake itself. Instead, when the ground moves beneath a building, it displaces the foundation and lower levels, sending shock waves through the rest of the structure and causing it to vibrate back and forth. Okay, the last one is explosion. Earthquakes as a result of detonation of nuclear or atomic bomb. Explosions and earthquakes both release a large amount of energy very quickly and both can be recorded by seismic instrument. However, because the forces involved in each are very different, the waveforms that each creates look different. Okay, so those are the 5 hazards associated with earthquakes: the ground shaking, surface faulting, tsunami, collapse, and of course, the explosion. Seismic waves are mechanical vibrations that occur inside the earth along fault lines, which is caused by the breakage of rocks. These waves are sound waves traveling through and across the earth that are produced by earthquakes. The instruments that record earthquake waves, or the seismic waves in general, are called seismographs. The records produced by the seismographs are called seismograms. I repeat, the instrument used is what we call seismograph, while the records produced by the seismograph is what we call seismograms. Okay? Okay, so there are 2 major types of seismic waves: the body and the surface waves. Body waves includes primary and secondary waves, while surface waves includes Rayleigh and lava waves. The first one is body waves, waves that travels through the interior of the earth. There are 2 types of body waves, the primary and secondary waves. Primary waves, also known as P waves, are waves that push or compress, pull and expand rocks in direction the wave is traveling. This type of wave can travel through solid, liquid, and gas. That's why this is the only type of wave that can travel all the major phases of matter, which is a solid, liquid, and gas. The other one is secondary waves, also known as S waves, are transverse waves that travels slower than P waves, and it can travel through solids only. So meaning, the difference between the 2 types of body waves is that primary waves can travel through solid, liquid, and gas, while secondary waves can only travel through solids. The other one is that primary waves is faster compared to secondary waves. Okay? The second type of seismic wave is the surface waves, waves that travel only on along the ground. There are two types of surface waves, the love and Rayleigh waves. Love waves can travel along surface of the Earth from the point directly above the epicenter, and it is the most damaging type of surface waves. Love wave was named after Augustus Edward Love. The other one is Rayleigh waves. It can travel along the free surface of an elastic solid such as the Earth, and it spread out most in time, producing long wave duration on seismograph. Rayleigh wave was named after John William Stratt, 3rd Baron Rayleigh, or also known as Lord Rayleigh. The difference between the two is that the motion in Rayleigh waves is a combination of longitudinal compression and dilation that results in an elliptical motion of points on the surface, while love waves travel only through the lithosphere of the Earth that cause ripples on the surface. That's why love waves is considered as the most destructive type of seismic waves. The two important features of an earthquake are the focus, which is the location on the fault where movement begins or the source of seismic waves. In short, focus is the origin of the seismic waves. And epicenter, which is the line or point on the surface directly above the focus. The epicenter is the reason why earthquake has its name. Epicenter can be located by using seismograms from earthquakes. From these, travel time graphs are constructed, then the distance separating the recording station from the earthquake can be determined by, number 1, the time interval between the arrival of the first P wave and the S wave. The other one, find on the travel time the equivalent time spread between the P and the S wave curves. Okay, so what is the difference between intensity and magnitude? An indication of the destructive effects of an earthquake at a particular place is known as intensity. It also describes how strong an earthquake was at a particular location. This is affected by factors like distance to the epicenter and the nature of the surface materials. While magnitude is the total amount of energy released during an earthquake, it describes how earthquakes can cause damage. Much larger numbers of earthquakes of smaller magnitude occur very regularly due to the meeting of major tectonic plates in the region. In 1935, Charles Richter of California Institute of Technology introduced the concept of earthquake magnitude. And today, I find Richter's scale is used worldwide to describe earthquake magnitude. In our country, people nearby the West Valley Fault System are expecting a magnitude 7.2 magnitude earthquake from the West Valley Fault, which is expected to hit Metro Manila and Quezon City. This is called the Big One. It could destroy about 40% of residential buildings and damage 35% of public buildings. It could also result to 34,000 casualties, 114,000 individuals will be seriously injured, and the possible fire incident that would follow could add another 18,000 deaths. The risk of possible earthquakes in various areas in the Philippines, based on geologic profile and history of seismic events, are shown on the hazard map. According to PHIVOLCS, the top 10 provinces that are at risk to earthquakes are Surigao del Sur, La Union, Benguet, Pangasinan, Pampanga, Tarlac, Ifugao, Davao Oriental, Nueva Vizcaya, and Nueva Ecija. As you can see on the hazard map of the Philippines, the red one is at high risk, the orange one is at medium risk, while the yellow one is at low risk. So here in Region 2, in our region, as you can see on the hazard map, we are at low risk in terms of earthquakes. Okay, so now that you learned about the fundamentals of earthquakes, you should know what to do before, during, and after the earthquakes. Also, every member of the family should know how to prepare the disaster or emergency kits at home. The other type of geological hazard is the volcanic eruption. The Philippines is one of the countries with a lot of active volcanoes. as part of the Pacific Ring of Fire, associated with almost 450 volcanoes, wherein 75% are active volcanoes, we cannot deny the destructive effects of these volcanoes. History shows that casualties and damages were prevalent during eruptions. So volcanic eruptions is the process in which volcanic materials such as molten or hot fragmented rocks and gaseous substances are ejected from a volcano. The Philippines is especially exposed to the hazard of volcanic eruption because our country is located along the Pacific Ring of Fire. A volcano is classified based on its activities. PHIVOLCS classified volcanoes as active or inactive. Active volcanoes erupted within historical times, within the last 600 years. Accounts of these eruptions were documented by men. Erupted within the last 10,000 years based on analysis of datable materials. The other one is inactive volcanoes, which is no record of eruptions. Physical form is being changed by agents of weathering and erosion. Other experts classified volcanoes as dormant or extinct. Dormant is a type of volcano rested for several years after eruption, while extinct meaning no signs of eruption for a long time. Volcanoes can also be classified based on their eruptions. So there are 5 types: the quiet, explosive, intermediate, fissure, and caldera. The first one is quiet. Fluid lava spreads out quickly to form a broad cone with gentle slopes and called as oozing, or non-explosive but sends fountains of lava hundreds of feet into the air in spectacular scarlet tongues. When it overflows, it can destroy and bury everything in its path. The second one is explosive. Explode with unbelievable violence, and the eruption is often preceded by loud rumblings and earthquakes. These open up the ground, forming that great fissures, draining lakes, and developing hot springs. The third one is intermediate. Eruption is sometimes quiet, sometimes explosive, or a combination of both. The fourth one is fissure. The largest amount of volcanic materials are extruded from cracks in the crust and rather than build a cone. These long narrow cracks distribute volcanic materials over a wide area. And the last one is caldera, a volcanic crater that exceeds 1 kilometer in diameter, roughly circular and mostly formed when the summit of a volcano collapses into a partially emptied magma chamber below. Volcanic activities may also be followed by other related hazards such as lahar flow, ashfall, pyroclastic flow, ballistic projectiles, emission of volcanic gases, and lava flow. These hazards prompt the evacuation of affected communities because of the significant changes in the physical and biological profile of the environment. Though volcanic eruptions can harm and damage properties and cause death, there are still reasons why we should be thankful of things or materials that volcanoes are ejected. So here are some of the economic importance of volcanic materials. First one, lava, volcanic ash, and dust form fertile soil which supports productive farms in Albay, which is the Mount Mayon, and other areas with active volcanoes. Another one, lahar from Mount Pinatubo is a source of feldspar for glass making, pottery, or porcelain production. It can also be converted to crystallized glass ceramics as a substitute for marble for floor and wall tiles. The last one, volcanoes that have lost its explosiveness can be tapped to provide geothermal steam for power generation. And the last type of geological hazard is landslide. So large mass of rocks descending from a high place. Landslide is a slipping mass of land from a higher to a lower level. Usually, if the soil is not compact and devoid of vegetation, gravity can drive soil and rocks to slide. There are many natural factors that can induce a landslide, such as wind and water. Landslide can also be triggered by rainfall or earthquake. Okay, so there are two types of landslide, the rainfall-induced and the earthquake-induced landslide. So the first one is rainfall-induced landslides. So in sloping areas, the gravitational descent or loosened soil makes it possible for landslide to occur. This is a common phenomenon in places with tropical climates after very intense and long rains during the wet season, just like what happened in Benguet, in Otagon, Benguet. Landslides could especially be serious in densely populated areas where weak and heavy structures are built on slopes. And the other type is earthquake-induced landslides. This type of landslide happens during or after an earthquake, when a piece of weakened landslide off primarily due to gravity. The development of frail rock or soil foundation may be due to the natural makeup of the soil consisting of a softer layer beneath soil bedrock. Actually, landslide can be man-made. So the following are the human causes of landslide, just like removal of vegetation, leaking pipe and sewer reticulation, modifications of slopes due to constructions of roads and buildings, overloading slopes, mining and quarrying activities, vibrations from blasting, operations of big machine, traffic, etc., and of course, excavation or displacement of rocks. Just like what is happening right now, if you're familiar with the white sand project in Manila Bay, also known as the Dolomite sand. Okay, so that ends our discussion for this week. So those are the different geological hazards, the earthquakes, volcanic eruptions, and landslide. By next week, we're going to continue our discussion about natural hazards, mitigations, and adaptation, about hydrometeorological and coastal hazards. Okay, so that's all for today. Thank you for listening and have a good day ahead.